Right. So today we will continue with computer systems. So by the way, next week the university has set up some institute meetings. So there we will be getting the new syllabus, okay, officially. So therefore, from next week onwards, we can speed up because I have been doing a little bit slowly as well because of there's a bit of an uncertainty because still we haven't got the official finalized syllabus for the new syllabus, okay? That happens every 3 years, okay? But the university has set up uh, the discussions next week. So therefore, by next class, we will be having the uh, official syllabus for you, okay? So that otherwise there's always bit of uncertainty, okay? So that is why I'm doing just stable topics, okay? Right. So now we are moving to our third topic. So we have done the introduction to computer. Evolution of computer also. Evolution have we done? History have we done? If not, we need to do that first. No, we haven't, right? It's called computer. Yeah. So let's do the evolution of computer part first. I thought we have done it. I think we did that, right? Let me double check. Yeah, we did that. Okay. Yeah, we did that. The evolution part we did. So let's move on to the representing data. Okay, representing data. And of course, then we'll move on to the logic or the how the data is processed. Okay, right. So now we are more into the serious stuff. So this topic, the note is available in your Google Classroom because these topics are stable, right? These topics are not going to be changed at all. Okay. Under computer systems, right? Number systems. That is the theory part. So then the application representing data in computer, right? So this is the most boring topic in computer system because there are interesting topics, boring topics. Sometimes we need to do a bit of boring topics as well. Okay, right. So we'll do the theory part first. It's like a maths topic. Then we'll move on to representing data in computer. Okay. And we are going to start two topics parallelly, that is representing data and process data, because mainly because this topic is boring. So therefore, I want to do parallelly do two topics. One is boring representing data, other one is the interesting uh, processing data. Okay, right. But let's first start the boring part, that is representing data. Okay. Right. So remember, the computer represent everything as quantities. So as humans, we can sense, we can understand both quantities and qualitative things. For example, beauty. So we can understand, we can sense. But quality is a qualitative thing. We don't always scale it. But for computer also, yes, computer can understand both quantitative and qualitative things. But the difference is everything is ultimately converted into a quantity by computer. Even when we say hi, something like hello, apple, text, like, so that is also set of ones and zeros. Or it's basically numbers, say 75, 89. So then it is converted to binary. Even image is set of ones and zeros. So ultimately, for computer, everything is set of ones and zeros, so set of numbers. And not only it's a number, it's a binary number. So that is why we are interested about number bases. Okay, number bases. Right. So remember, therefore, now let's concentrate on it as a maths topic. Of course, you have done this in your grade 8, 9. This is a quick revision only. You are not going to learn anything new. Maybe little bit new. Little bit we move to advanced topics, but 80% what you have learned in your grade 8, 9. Right. So when it comes to number, right? So number represent a quantity. A number represent a quantity. Like 5, 2.8 minus 3, right? Half, 2 out of 3. So numbers represent quantities. Okay. So when it comes to representing numbers, of course, there are different type of numbers and so on, like integers, fractions or decimals, even irrational numbers and so on. Whatever the type of number, when we refer to a number, every number has a base. So the general base we use is base 10. Ordinary. When we say 5, it's base 10 5. When I say 2.8, it's base 10 2.8. Even when I say half, it's based on base 10. Okay. For some reasons, as humans, we have selected base 10 as our preferred base, ordinary. But it doesn't mean that base 10 is the only base. No. It can be anything bigger than 1. Base 2, base 3, base 4, base 5, and so on. Right? All these concepts can be practiced using any base. Whatever we do with base 10, we can do with base 2 or base 5 or base 7 or base 16. Okay, so just base 10 happen to be our preferred base. Okay. But when it comes to computer, the computer engineers, scientists have decided, agreed, let's use base 2 to represent all the quantities or numbers. So that is a consciously taken decision. In a way, it's difficult for us to understand how the computer work or how the computer represent data because we are not that familiar with base 2. So then why computer engineers, scientists have taken that decision? Because base 2 is more natural because we are not, it's not humans that going to process. It's going to be processed by again electronic devices. So when it is basically it's going to be processed by digital circuits, Boolean logic. Right? So Boolean logic is two-state logic. Two-state logic. True-false logic. So when it is going to be processed by two-state logic, if the data is also in two-state or binary, that is much easier. Otherwise, anyway, we need to convert it to binary. So therefore, the easier thing is just represent it in binary itself rather than you convert it at the processing time. So that is why we are really interested about base 2 or binary. So that is not to make our life difficult. That is to make our life easy because anyway, this is how the data is processed. Okay. Right. But our discussion is not only limited to base 10 and base 2 because base is a general concept in maths. Right? It's a general concept in maths. So therefore, if you want to get the confidence about number bases, you don't just be a slave of base 10 or maybe just slave of base 10 and base 2. So you just consider base as general concepts. So you must be okay. You must be familiar or you must be comfortable with any base. So then you are really comfortable or you are really confident. Okay. That is why we don't, when we do exercises, we don't just limited to base 2, we will take base 8, base 16, even base 5, base 3 or whatever. Okay. So that is to give you that confidence. Because otherwise what happens is you can't say, I know how to add numbers. Maybe you can say, I know how to add numbers in base 10. But if you can do it in any base, at two base 5 numbers, at two base 12 numbers, so then you can confidently say, I know how to add numbers. Okay. For example, if you can do this 3, 5 in base 7 plus 6, 4 in base 7. If you can add these, I will say you know how to add. But if you can't do that right now, so don't say I know how to add. Maybe you can say I know how to add 75 and 39 in base 10. That means you don't know how to add. You know how to add in base 10. But here, if you don't care whether it's base 7 or base 6 or base 12, then you can proudly say, I know how to add. So that is the level of confidence you need to get. Okay. Right. But we will be more interested about base 2, obviously, because computers use base 2, and also base 8 and 16, because we frequently keep data in base 8 and 16 as well, like IP addresses, color numbers, because it's very easy to convert to base 2 from 8 and 16 rather than base 10. Okay. But it doesn't mean that we are only limited to these three bases. Uh, so any base, you should be able to work with any base. That is to give you that confidence. Right. So therefore, what we are going to do is you should be able to convert from one base to any other base, but especially base 8 to 16 and 10. And you must be able to do addition, subtraction, multiplication, division in any base, and especially these four bases. But in general, in any base. Okay. Right. So let's start with base 10 because that is what we are familiar. Okay. So in base 10, we have 10 digits, 0 to 9. So base 10, 10 digit means base 2, we have 2 digits. Base 8, we have 8 digits. Base 16, we have 16 digits. Look at the patterns. If someone says base 7, then we should have 7 digits. And if it is base 10, those are 10 to the powers. That is 10 to the power 0, 10 to the power 1, 10 to the power 2, 3, 4. So then if it is base 2, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. If it is base 5, 5 to the power 0, 5 to the power 1. So you need to look at the pattern. So intelligence is all about, not all about, a key part of intelligence is can you see the patterns quickly, effectively? So then we say you are intelligent. So that is why in IQ test, right? If you have faced any IQ test, I have faced many IQ tests in my life. So most of the questions are to check whether you can see the pattern. What is the next number, which image is the next image, or which image is not relevant here, and so on. So basically they check whether you have the pattern. Can you identify patterns quickly? Because that is IQ. So similarly, you must identify these patterns now. Base 10, 10 digits, base 8, 8 digits. Base 10, 10 to the power 0, 10 to the power 1, 10 to the power 2, then base 7, 7 to the power 0, 7 to the power 1, 7 to the power 2. So then how do we add in base 10? Then add up to base 3, base 5. Okay. So then all of a sudden you are very general. You know how to do things at very high level, high abstract level. Okay. Right. So therefore, if someone asks you to look at something like this in base 10, what does this mean? This is 10 to the power zeros, 10 to the power 1, 10 to the power 2, 10 to the power 3. Or in other words, these are ones, tens, hundreds, and thousands. So that is why we say 8,725. It makes sense. Okay. Now let's use the same concept idea for other bases. Let's move on to binary. So if base 10 has 10 digits, base 2 has 2 digits, 0 and 1. And now we have the 2 to the power zeros, 2 to the power 1s, 2 to the power 2. So 1, 2, 4, 8, 16, 32, 64, and so on. Okay. So therefore now if you are given a binary number, you must be able to convert it to denary or base 10 by knowing what you are doing, not like a calculator machine. Remember, intelligence is not doing things for the sake of doing or because you are asked to do like that. Rather, you doing it with proper logic, formal logic, knowing why you are doing like that. Okay, right. 1 0 1 1 0 1 0. So when you see something like this, never ever say 110 in base 2. The moment you say 110 in base 2, you show that to the world you don't know what you are talking. Right? So the moment you say 110 in base 2, so it highlights that you don't know what you are talking. Sometimes that is why we said when you don't talk, sometimes it's better, especially if you don't know what you are talking. Okay, so then you better keep your mouth shut, or you learn it properly and start talking more. Of course, you need to start talking when you want to clarify things and so on. That is a different story. But in general public, right? So therefore, never ever say 110 in base 2 or never ever say this is 375 in base 8. So this is 375 in base 8. This is 110 in base 2. Why? Because these are ones, twos, fours. So therefore, this is not 100, this is 4. Right? This is 8 to the power 0, 8 to the power 1, 8 to the power 2s. So therefore, this is 64 into 3, not 300. 64 into 3 is not 300. That is why I'm telling never ever say 375 in base 8. Okay. Right. So let's move on to this one. Say this is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, and 2 to the power 7. In other words, 2 to the power 0 is 1, 2 to the power 1 is 2, 4, 8. Now you can see the pattern, right? Multiply by 2, 16, 32, 64, 128. So we have no ones, we have 1 twos, 1 fours, 1 16, 1 32, and 128. Now we add it just like we said 300s to 10s, right? And so 8 plus 2 is 10, 22, 3 plus 2, 5, 6, 8, 100 and now I can say 122 because this is base 10. Yeah, I hope I did make a mistake. Oh, I have made a mistake. Where is that mistake? 32, 2 fours. Oh, I think I have written different number here. 10110. Yeah, 110. This is different, right? I think this answer is correct because I have what I have written is not this one. Okay. Right, don't worry. Right, I think we did it correct for our example. Let's double check. 1, 2, 4, 16, 32, 128. 128 plus 32 plus 16 plus 4 plus 2, 2. Okay. So 8 plus 2, 10, 20, 22, 2, 4 plus 7, 8, 8 plus 1, sorry, 10, 10, 8 plus 2, 10, 20, 22, then 3, 6, 8 and then 1. Yes, 182. Okay, 182. Of course, this example is different from this one. Okay, I do this as exercise. Convert this into base 10. I do only one example because I know that a lot of students don't like maths because the teachers have asked them to do too many questions. Okay. ගණන් හදනම ගණන් එපා වෙලා. ඒක නිසා එපා වෙන්න කලින් අපි ගණන් හදන එක නවත්තනටක් ගන්න. Okay. ඇට්ටක් ගාලා කරන්න එකයි දෙන්නේ ආ. Because you have anyway done this in your 8 9 101 0010. Convert to binary, sorry, base 10. And make sure you do it knowing what you are doing, the logic, theory. Okay, why we are doing like that. So that is what your character is, your personality is. And you can, when we know more and more, you can make it faster, efficient, skip some steps. That is with knowing what you are doing. Right? For example, now I can say straight away, this is 1, 2, 4, 8, 16, 32, 64. So therefore it is 64, 16 and 2, which is 92. Okay, 92. Sorry, 82. Yeah, 6 plus 1, 7, 7 plus 1, 8, 82. Okay, right. So what about the reverse? That is binary to decimal. What about the decimal to binary? So you know how to do that in your grade 8, 9. First, try to explain it in a simple English, precisely. Okay. So how do you do that? You take the decimal number, you keep divide by 2 and keep writing the remainders. When you get to 0, you stop and write the remainders in the reverse order. Sorry. So let's take one example. Let's convert 18 into binary. 9 nothing, 4 1, 2 nothing, 0 1. But when you get 0, you can stop and write it in the reverse. So that is the answer. Okay. I do this as exercise. Just one example. And of course, if you are a lazy person, right, IT is not the subject for you. Okay. So engineers build the next generation, next civilization. So you can't build the next civilization and lazy, right? Either you need to select one of those, right? For lazy people, there are other jobs, but not for engineering, right? Technology related subject. At 7, 8, nothing, 3, 9, nothing, 1, 9, 1, 9, 1, 4, 1, 2, nothing, 1, nothing, 0, 1, 1, 0, 0, 1, 1, 1, 0, 0. You can double check 1, 2, 4, 8, 16, 32, 64, 128. 128 plus 16 plus 8 plus 4. 10, 16, that is 26. 5, yeah, 156, correct. 100, triple 100. Okay. Right. So that is how you convert binary to decimal or denary, denary to binary. So the same concept is applicable to whether it's base 5, base 7, base 16, base 20 or whatever. Simple as that. Only thing is your 2 will become 8 if it is octal and 16 if it is hexadecimal and so on. Okay. Right. But anyway, we will visit one by one. Right. Right. Octal. But basically, I don't need to do this because just replace 2 with 8 rather than divide by 2, you divide by 8. Rather than 2 to the powers, it's 8 to the powers. But anyway, let's do one example for each. Of course, if it is octal number, we have 8 digits, 0 to 7. Right? Just like base 10, 10 digits, 0 to 9. And how to convert octal to base 10? You just take 8 to the powers and sum it. Right? Convert this into decimal quickly. Again, don't say 154. 154 in base 8. Convert it into base 10. Right, quickly do it because this is the only example I'm giving to you. So I don't want to give you so many questions and frustrate you. So in Sri Lanka, we overfeed, overteach, so many things, right? And also do it fast because you must be an active person. Right. 4 into 1, 5 into 8, 40. 64 into 1, 64. 108. 118 base 10. Okay. Right. So reverse. Convert 106 in base 10 into base 8. Just one example. Convert it to base 8. Because I'm giving only one example exercise, just do it, okay? And finish it here itself. Then you don't need to again study, right? You study and finish. Right, so we need to keep divide by 8. If you find it difficult to divide like this, divide in normal way. Right? Even I do like that. 1, 8, 26, 3, 24. 2 remains. So 13, 2 remains. 1, 5 remains. 0, 1 remains. 1, 5, 2 in base 8. Okay. 1, 5, 2 in base 8. Right. So that is decimal to octal. Okay. Let's move to hexadecimal. In hexadecimal, we have 16 digits. What are those digits? 0 to 50. Now, because we are running out of, because we use base 10, and now we need more digits. So you can introduce any symbols you like, but everyone must agree. So therefore, usually we borrow symbols from English alphabet because we need up to 50. So typically we take A, B, C, D, E, F. Okay, right. So now you know what to do. How to convert hexadecimal, because hexadecimal can have up to F now. Hexadecimal to decimal. Now you have 16 to the power 0, 16 to the power 1, and so on. Okay, right. Convert this number into base 10. This is the only exercise for you. Right, 16 to the power 0 or 1, 16 to the power 1 or 16, 16 to the power 2, that is 16 into 60, 256. So we have four ones. B means A is 10, B is 11. 11 into 60, 176. And 1 into 256, 10, 16, 13, 436. Yeah. Right, so that is how you convert hexadecimal to decimal. Now, other way, decimal to hexadecimal. So you're supposed to keep divide by 60. Now the remainder can go up to 50. If the remainder is 10, you take the remainder as A and so on, right? Now use common sense, logic, right? Right, do this as exercise. 984, convert it to hexadecimal. And take 1 minute. So now we are doing the mathematics part. Then we have the usage, how the computer represent data. Right. So let's keep divide by 16. 984 divided by 16. 6, 6 into 6, 36, 3, 96, 24, 1, 16, 8. So therefore it is 61, remainder 8. 3, that is 48. 61 minus 48, 13. So 13 means A, B, C, D. 10, 11, 12, 13, D. And of course, this is 0 and 3. You write from top, bottom to top, 3D8. Right, 3D8. 3D8, okay? Right, exercises you're supposed to do by yourself. Right, so the next thing is, because binary, octal, hexadecimal are related, because all are 2 to the powers, it's easier to directly convert between these. Actually, the computer directly convert binary to octal, octal to binary, binary to hexadecimal, hexadecimal to binary, and so on. So therefore, we must familiar with that also, because if the computer can do it, we must also aware of that, right? Right, how to convert? One is, of course, if you are given a binary number and ask you to convert to octal, one way is, as a human, you convert this to base 10 and then base 10 to base 8. But if the direct conversion is easier, why don't we learn it? Right. So this is how you convert binary to octal. When you are given a binary number, so let's take an example like this. Say 111 11010. You break it into chunk of 3 starting from right side, right 10. Okay. 123, 123, and so on. So then convert each 3-digit binary into base 10, but it will be a valid octal number because the maximum is 7111. This is 124, that is 2. 1 plus 2 plus 4 is 7. 1 plus 2 is 3. And the final answer is 372 in base 8. I never say 372. 372 in base 8. So it's very fast. Okay. So you break it into chunk of 3s from right hand side. Convert each chunk of 3 binary number into base 10 and it will be a very octal number. And that's it. Okay. Right. Do this as exercise. Do this as exercise. We don't care how many digits are there. It's because you take 3 digits at a time. Right. So let's make it 1, 2, 3, 1, 2, 3, 1, 2, 3. This is 1. This is 1 plus 2, 3. 2 plus 4, 6, 7. That's it. 7, 6, 3, 1 in base 8. Okay. Right. So next one is octal to binary. So it's a reverse process. Now you know the logic. That just reverse the logic. Right. Say now you are given the octal number and you can directly convert it to binary rather than going through base 10. So what is the reverse logic? Convert each octal number thinking it like a base 10 number, but make sure you write it as 3-digit binary and prefix 0 to make it 3-digit. So 2 is 0, 1, 0. 1, 2, 4. 5 is 4 and 1. 1, 0, 1. 1 plus 4. 2 is 0, 1, 0. 6 is 1, 1, 0. That's it. Simple as that. Okay. Right. Convert this one. 4, 2, 6. 4, 5, 6, 2. Now do it quickly. Right. 2 is 0, 1, 0. 6 is 1, 1, 0. 5 is 1, 0, 1. 4 plus 1. 4 is 1, 0, 0. And that is your binary number. Okay. Right. So same logic is applied when you want to convert binary to hexadecimal and hexadecimal to binary. Only thing is now you rather than think of chunk of 3 digits, you think of chunk of 4 digits because it's 2 to the power 4 is 16. Okay. Always look at the patterns. Let's straight away do an example. Say I want to convert binary to hexadecimal. Now you break it into chunk of 4 from right hand side. 1, 2, 3, 4. 1, 2, 3, 4. Now you write it as a base 10 number. You convert it to base 10, but write it as a hexadecimal digit. Because you can even get up to 15. 1, 1, 1, 1. Remember, rather than 15, you need to write it as F and so on. This is 1, 2, 4. 2 plus 4 is 6. This is 1, 2, 4, 8. That is 14. 14 is A, B, C, D. 10, 11, 12, 13, 14. That is C. Final answer is E6. E6. Okay. Right. I will explain it again. So if you want to convert binary to hexadecimal straight directly, of course, one approach is convert this into base 10, then base 10 to hexadecimal. If you want to convert directly to binary to hexadecimal, take your binary number, right? From right hand side, break it into chunk of 4, group of 4 digits, 1, 2, 3, 4. 1, 2, 3, 4, and so on. Then convert each chunk, each group into base 10, but write it as a hexadecimal number because you can get even 1111, which is 15. So 15 in hexadecimal is F, right? 1110 is 15. Sorry, 14, which is C, and so on. So here 1, 2, 4, 4 plus 2 is 6, 6. This is 1, 2, 4, 8. 8 plus 4 is 12, 12 plus 2 is 14. 14 in hex because you are supposed to write it in hexadecimal digits. So 14 is A, B, C, D, E. 10, remember A is 10. 10, 11, 12, 13, 14. So therefore this is F6, direct conversion. Right, direct conversion. So rather than chunk of 3, you think chunk of 4. Okay. Okay. Right. So do this as exercise. Convert this into hexadecimal. Do the direct conversion. Because we are going to convert to hexadecimal, now we are going to break it into chunk of 4. From right hand side. It's a technique. Then convert it to decimal, but write it as a hexadecimal digit. So this is 3. This is obviously 7. This is 1, 2, 4, 8. That is 13. 13 is A, B, C, D. 10, 11, 12, 13. D. And this is 7. 7D73 in hexadecimal. Okay. 7D73. And of course, you can do it in the other way. If you are given the hexadecimal, take every hexadecimal number digit, but consider it as a decimal digit and then convert it to 4-digit binary. If it is less than 4 digits, you need to prefix zeros to make it 4 digits. Okay. Earlier, 3 digits. Now 4 digits. Okay. Right. Do it by yourself. B5A. Convert it to binary directly. Take the binary value of the hexadecimal digit, convert it to 4-digit binary. Do it for each and every hexadecimal digit. Right? So take the base 10 value of the hexadecimal digit. A is 10. Convert it to binary. 5 nothing, 2 1, 1 nothing, 0 1, 1 0 1 0. Make sure it's 4 digits. And 5 is basically 4 and 1. 1 0 1. 1 2 4. 4 plus 1 is 5. Remember, B is 1 plus A. Use common sense, right? Rather than converting, I can add 1 to here. That is 1 0 1 1. So this is your binary number. Okay. Right. So this is an exercise to check whether now you have got it. Because we have discussed only about octal, hexadecimal, binary, denary. So now if you can generalize these concepts, do this exercise. Convert this into base 5. right? Because now you're supposed to convert it to base 5. You are supposed to repeatedly delete by 5, right? 87, 15, 735. 17, 2 remains. 3, 2 remains. And nothing, 3 remains. So therefore it's 3, 2, 2. Right? 3, 2, 2 in base 5. Right, next exercise. Convert this base 50 number into base 10. This is a base 15 number. So base 15 number can have up to E, 0 to 14. Right, 2BA. That means 15 to the power 0, 15 to the power 1, 15 to the power 2. In other words, ones, 15s, 15 into 15 is what? 225, right? So A means 10, 10 number of ones. B means 11, 11 number of 15, 165. 2 number of 225 is 450. 625. Okay, 625. Right, right. So we'll stop at this point, the number theory, because I told you we are going to do it. We are going to start both representing numbers and logic together, because this is more boring part. Logic is the interesting part. So therefore, we'll take a break. After the break, we are going to start our next topic, because we have the big topic, uh, representing data in computer, then processing data, and then the computer architecture. Okay. Uh, Processing data or the logic, but that is after the break. Okay. Now it's 2:25. We'll start at 2:45. And the note, I think I have enabled. Let me double check. Okay. Yeah, Boolean logic. Okay. That is the theory part. Just like we have the number bases theory part, representing data application part. Here, Boolean logic theory part, digital circuit design application part. We are going to start the theory part. Okay. Right. That is 2:45. Okay. So let's continue. Now we move on to our next subtopic. We have not finished representing data. We are going to do this parallelly. That is processing your data. Because remember, computer is all about data processing. Store, process, and transmit. Transmission is basically something we cover in networking topics. Okay. Right. So I already mentioned you that computer represent everything as binary numbers or binary data. And at hardware level, computer process everything using Boolean logic, right? Boolean logic or true false logic. So if someone asks how the data is processed, uh, you can give the answer at different levels. One answer is your data is processed by your programs, Java program, C program, Python program. You write the logic, or software engineers write the logic using those languages. But in reality, at low level, your data is represented by set of ones and zeros, so digital signals, and these signals going through logic gates and get processed to get a different signal or set of signals that represent your final set of results or information in binary, which you can interpret whether it's text, image, audio, video, and so on. So therefore, at a hardware level, how the data is processed, it's processed by applying Boolean logic operations. So that is why we are interested about Boolean logic. Okay, Boolean logic. Just like we are interested in binary numbers, we are interested in Boolean logic. Right. First of all, we need to understand what is mean by logic. Okay, logic. Logic, the word logic is highly exploited, misinterpreted word, just like science. So people use the word science whatever they like, right? So similarly, they use the word logic to whatever they like also. Therefore, first of all, you need to identify what kind of logic we are interested as well. So basically, the general term is we use logic to reason out things, right? Reason out things. We need to understand, we need to find the reasons why is it happening like that. That is to understand things that has happened and also predict what is going to happen in the future, right? So in order to do that, we can use logic. But again, so one person might say, okay, this is how it happens. This is the logic. Another person will say, no, this is wrong. Your logic is wrong. So that is why we say it's sort of it depends on the person, your beliefs, and so on. So, so therefore, it's for one person, the logic is acceptable. For another person, the same thing may not be acceptable. But you know that computer is very reliable device. So in general, we have no issues with using computers, right? In general, of course, there can be people even they have issues with they question the use of computer. That's a different story. But in general, right? When we use computers for our banking systems, inventory management, right? Order processing, usually we don't have any issues, right? So that means we don't have any issues with the logic that we use in computers. Okay. Especially the debate is belief systems, right? Something one person believe may not be something another set of people believe. So therefore, let's not go into that territory. Rather, let's just stay it is formal logic. So therefore, we will use the word formal logic to understand the logic that we use in data processing in computers. Formal logic, scientific logic, right? formal logic. And we will take all the other logic and belief systems into informal logic. We are not interested in that in our subject, right? We are not interested in these things. We are interested in formal logic, that is scientific logic, okay? Because it's not opinionate. It's something that we all accept in general. In science, engineering, scientists, engineers, right? Philosophers, we accept it in general, okay? Right. So when it comes to formal logic also, there are different type of logic. Okay. Different type of logic. So out of those, the most widely used and the most widely understood type of formal logic is Boolean logic. Right? Boolean logic. So it doesn't mean that Boolean logic is the only formal type of logic. No, but this is the most reliable, most widely understood type of logic. And this is what we mainly use at hardware level. This is what we mainly use for data processing also. But other than that, there are some other formal logic as well, probabilistic logic, some sort of fuzzy logic. So those are for the AI. Right? If you want to further study about AI, so you need to go beyond Boolean logic, like neural networks, fuzzy logic processing. So, but we will be concentrating on Boolean logic because this is the good starting point. Okay. Now we have eliminated the any logic other than formal logic. And inside formal logic also now we have narrow it into the Boolean logic. Okay. For our discussion. So what is Boolean logic? Boolean logic is the word Boolean comes from a mathematician's name, George Boole, who contributed to the logic subject in early 1990s. I think yes, early 1990, I think latter part of 1980s. Sorry, 1800s. I can't remember. Maybe latter part of 1800s. George Boole. Yeah, right. Born in 8815, died in 1864. Right, middle part of 1800. Okay, 1800. A British mathematician, English mathematician. So we call it Boolean. That's his name, right? But basically, Boolean logic means two-state logic. True, false. Okay, true, false. 1, 0. On, off. Pass, fail. Because there are some other type of logic which can have multiple states. Probabilistic logics and so on. Those are also formal. But we are only interested in Boolean logic right now. Right? So these are the features. It's two-state logic. Boolean logic is applicable on propositional statements. So you can't apply Boolean logic to, for example, you know that arithmetic operations can be applied to numbers. You can say 5 plus 2, 8 into 3, but you can't say high plus 9. Okay. So similarly, Boolean logic operations are applied to proposition. That means a statement which is true or it is false. Okay. Propositional statements. So what kind of statements are the propositional statements? So that means if a statement is true, it's a propositional statement. If a statement is false, it's a propositional statement. So then someone will ask, how do you know whether it's a propositional statement or not? How do you know that it is true? How do you know whether that is false? Again, it can be debatable. Again, we don't go into those debatable areas. So we will always stay with formal scientific area, right? For example, if I say sun rises in the east, so is it debatable? No, right? We all see that in my life. I have always seen that the sun rises in one side of my house and sunset in the opposite side. And in general, we call it east. Sun rises in the east. For example, I live in the western province. I don't, if I go to the beach, I can see the sunset because I am in the western province, sunset in the west. But when I go to the eastern province, like Batiklo or somewhere, I used to go in the morning to see the sunrise. But in Colombo, I used to go in the evening to see the sunset. So that is in general truth, right? In any country, if you go to the eastern side, you can see the sun rise in the morning. Western side, you can see the sunset. So therefore, there's no debate, right? So therefore, when someone says sun rises in the east, yes, it is true. It's a propositional statement. At the same time, if someone says sun rises in the west, that is also propositional statement because it is false, right? It is false. Okay. And also, so there are standard knowledge like mathematics, formal science. So there also we can use be propositional statement. For example, 5 is greater than 2. Yes, we know that 5 is greater than 2 according to the formal knowledge of that we have built as math arithmetic. So then it's a propositional statement. And if someone says 5 is less than 2, that is also a propositional statement because we know that that is definitely false. If something is false, it's a proposition. If something is true, it's a proposition. If it is neither true nor false, so there are doubts, so sometimes it can be false, sometimes it can be true, so then it's not a proposition. So then don't apply Boolean logic operations. Is it clear? Okay. So proposition is a statement which is true or a statement which is false. I'm not saying true or false, right? True or statement which is false. Okay. Because we are going to continue this discussion on the maths in semester 2 because semester 2 big part of semester 2 maths is logic and sets. Half of the syllabus is logic and sets. Okay. Because for IT, someone doing IT computer science, our main subject is logic because computer process everything using logic. Okay. That is why you have IT mathematics for computing, not mathematics. So most of the time what you learn in your A level is mathematics for engineering, mainly civil mechanical engineering. That is why a lot of geometry and so on. But we don't need a lot of geometry, lot of algebra, 5T, computer science. We need logic, sets, probability, statistics, especially when we move on to AI, data science. Okay. Right. So then what are the examples of not a proposition? Right. Questions are not propositions because it must be a statement. For example, 5 plus 2 is 7 is a proposition. If someone asks, is 5 plus 2 equals 7? That is not a proposition because you're asking a question. Okay. Colombo is the capital of Sri Lanka, proposition. Because we all know Colombo is the capital, right? There's no debate about it. At least the commercial capital. But if someone asks, is Colombo the capital of Sri Lanka? That is not a proposition because you are not giving a solid statement. You are just asking questions from others. So then, if a statement is true or false, depending on the situation, time, values, it's not a proposition because it can be true, it can be false, depending on the situations. For example, 5 is an odd number, proposition. But x is an odd number is not a proposition because depending on the value of x, it can be odd, it can be even. And opinions are not propositions because it's your opinion, right? You can value your opinion, but it's you can't say it's a proposition, right? So that is why there are a lot of debatable things, right? For example, at the end of a cricket match, very little debate. But at the end of a beauty, right? Miss World, Miss Sri Lanka, at the end of a, say, literature, giving awards for the literature and so on, there are debates. Why? Opinionated. Which is the best book? Which is the best film? Who is the most beautiful? These are highly opinionated, but not at the end of a chess game. Okay? So opinions are not propositions. Okay? So opinions are opinions. Okay? So let's take an exercise. Right? Which of the following are propositions? So if you can definitely say without any doubts, uh, debates, it's true or it's false, it's a proposition. But when there are fuzziness, doubts, opinionated, it's not a proposition. Say x is a real number, x is greater than 5. So, so it can be greater than 5, right? Because if x is 2, yes, 2 is not greater than 5. But if x is 100, yes, 100 is greater than 5. Because real numbers can be negative, positive, fractions. So therefore, first one is definitely not a proposition. What about the second one? Now you need to think a little bit about seriously about maths as well. If x is a real number, x squared d is greater than or equal to 0. And you know that for any real number, when you square it, it's always greater than or equal to 0 because even negative numbers become positive numbers. So therefore, this is true. If it is always true, yes. Not sometimes, yes. So this is a proposition. Gold is the capital of Sri Lanka. It's a proposition. Why? Because we know that this is false. If something is false, still it's a proposition. And we say its proportional value is false. Right? If x is a positive even number, then x plus 2 is also an even number. Is it a proposition? Of course, yes. Because whenever x is a positive even number, when you add 2, it's also even. That is true for any of positive even numbers. It's a proposition. iOS is better than Android. That is opinion, just like beauty and so on. For one person, maybe he or she might say, okay, I think Android is better. iOS is not user friendly, difficult to use, and so on. So it's not a proposition. Okay. Right. So now we can identify two types of propositions because logic is applied to Boolean logic is applied to propositional statements. Okay. So what are those two types of propositions? Atomic propositions and compound propositions. Both are propositions. So atomic proposition is a proposition that means definitely we can say it's true or is it false. and we can't further subdivide it into smaller propositions. Atom means you can't break it. For example, 5 plus 2 is 8. It's an atomic proposition. Colombo is the capital of Sri Lanka. Atomic proposition. Then what about compound proposition? It's again proposition. You can specifically say whether it's true, whether it's false, but you can break it into smaller propositions. Smaller compound propositions or smaller atomic propositions. If it is a smaller compound proposition, we can further subdivide it until we ended up with all atomic propositions. But this statement itself is a proposition, right? For example, 5 plus 2 is 7 and 5 is an odd number. So we all know that 5 plus 2 is 7 is true proposition. 5 is an odd number is a true proposition, and true is true. So therefore this big statement is true. If a statement is true, it's proposition. If a statement is false, it's a proposition. But inside this proposition, you can see there are two smaller propositions. So how do you create compound propositions? By combining other propositions used in logic operators or Boolean logic operators. Just like by combining numbers, you get numbers. But there you need to combine using arithmetic operations. Okay. Similarly, if you combine propositions using logic operations, what you get is again logic or proposition. Here what you get is another number. So look at those things, similarities, dissimilarities, because learning IT is learning how the computer work is all about logic and numbers. Okay. Right. So therefore, how to create compound propositions? By combining other propositions using logic operations or Boolean logic operations. So then you must ask, what are the Boolean logic operators? Are there so many different logic operators? No, just few. Just like we have few arithmetic operations. Okay. So we have the not operator and or XO. XO is not a basic operator, but because XO is heavily used, we consider that as also as a basic operator. Right? Like those who have done bit of logic, maybe O level ICT, A level ICT. Can someone tell me why don't we take XO as a basic operator? Anyone? So this is an opportunity for you to build your character, right? Maybe your answer is wrong. That is fine. But at least giving answer means your thinking is working at least, right? So what I'm asking is something like this. We say that hydrogen is an element, right? We say that sodium is element, but we don't say water is H2O is element. Why? Why do we say that water is not element? And we know that yes, water is not element, water is a compound. So this question is similar to that. So why don't we say that XO is not really a logic operator, basic operator? Anyone? Because in real world, right, free and open world, you are supposed to face interviews, right? In the interviews, they ask questions. They don't give you exam papers. So you need to face this. because it doesn't validate simply find what excludes. I'm not very clear about that answer. It doesn't validate simply find what excludes. XOR gate can make using not O and yes. So simply, just like water, H2O can be made or broken down into elements, hydrogen and oxygen. So similarly, XO can be represented using these three operators. So therefore, we can build, if we can build this using these operators, so this is not a basic operator. It's just like H2O is not a element. H2O is a compound. Okay. So then why do we take it? Because it's very heavily used. Yes, we can take it. But at the same time, you must know that this is not a basic logic operator. Okay. Though we take it just like other operators. Okay. Because we can write XO as, if you will learn this later, A XO B as A and not B, or B and not A. It's logically the same. So that means without XO, you can write it using other operators. But that is not the case for this. You can't represent and use in not and no, or use in not and, or not use and no. Okay. So therefore, these three are basic operators. But because we heavily use it, we will look at it something like a basic operator. And even in digital circuits, we give it a symbol, right? Like this, just like you have O and so on, okay? Right. So remember, our task is understand logic operations, logic. So if you understand logic, right, basically you are in a very good position to understand the rest of the IT concepts, programming, how the computer works, how the database work. That is one advantage. So once you understand logic, one big advantage is now you are in a very good position to understand IT. Not only IT, science, engineering, because these are all based on logic. Science, engineering, business, accountancy, based on logic. And also, once you understand logic, you are in a very good position to understand how the society work, because that means you are a logical thinker. So logical thinkers have a better chance of survive in the society, right? So therefore, don't take this lightly. This is a very life critical subject, logic, for your career, for your life, okay? Career and life, especially for IT, engineering, science, medicine, business, okay? And of course, in general, your life. Because remember, we are humans, right? We are just animal. About 40,000, 50,000 years ago, we were not the dominant animal on Earth. You know, there was something called Ice Age. Before that, we had dinosaurs dominating the world, right? We were just another ape. But somehow in 2026, not only 2026, for last about 10,000 years, 5,000, 10,000 years, humans are the dominant animals. We dominate Earth. We control Earth. right? So the main reason is, remember, we are not the most powerful. We are not the biggest. We are not the fastest. We are not the strongest. We are not, but we are the most logical in general, right? It doesn't mean that everyone is logical, but average compared to other animals, humans have higher logical thinking capacity, higher critical thinking. So that is why we rule the world. We control the world. Okay, simple as that. So therefore, so it doesn't mean that just because you are a human, right? Within now, compared to other animals, yes, we have the higher logical thinking capacity. But within the society, as part of the human society, it doesn't mean that everyone has the same level of logical thinking, right? We don't have, right? Some people have little bit better logical thinking than the others, right? Even some nations have higher logical thinking than other nations. That is why we have, that is one of the reason why we have rich nations, poor nations. And whether we like it or not, we all know that Sri Lanka is not a rich nation, right? We are a poor nation. That means definitely our logical thinking is below the average, below average. And in the society also, there are levels, right? More logical thinkers, less logical thinkers. So think about this, because that is why I'm telling you, this is the most important subject. You may have learned so many subjects, right? Chemistry, physics, languages, but this is the most important subject that gives you the power. Power. Either you will be ruled by others or you can rule others. I don't want you to rule others, but at least get your independence. So you don't want to be ruled by others, right? I don't want to be ruled by others. At the same time, I don't want to rule others, but at least I don't want to be ruled by others. As much as possible, I value my independence, freedom. So how do you get that freedom? In your societies, human society. Be a logical thinker. Be a logical thinker. Okay. Now we have a new challenge also. For the first time, our supremacy has been challenged. Because remember, we proudly say we are the most logical thinkers on earth. But in about 20, 30 years, we are going to see an interesting phenomena. That is, we are going to see AI, artificial intelligence, which are more intelligent than humans. Still not the case. In narrow areas, yes. For example, now we can't play chess with AI. AI always win, always win. But on that machine, only good at AI, right? Sorry, only good at playing chess. But maybe some other areas, yes. But in about 20, 30 years, we call it artificial super intelligence, right? Artificial super intelligence. Still, we have not achieved that. Their AI is going to outperform human intelligence in general. So then we can't say we are the most intelligent animals in the world or on earth, because AI agents, AI units are going to be more intelligent than us. So that is why already some people have already uh, warned there's a risk. There's a risk which we need to address. Of course, we can handle it, but at the same time, we never know, right? You know that there's a risk of atomic power, atomic bomb destroy human society. It's a risk, right? We all live with that risk. But at the same time, still it has not become a reality, right? So similarly, there's a risk of AI or artificial super intelligence, but it doesn't mean that it will always be a threat to us. Maybe we can handle it. Okay. So therefore, this is super, super important subject, right? Logic. Okay. Your personal freedom to the supremacy of humans and so on. Okay. Right. So therefore, we must try our best to understand logic. We must use all the tools, approaches, methods to best understand logic. There's nothing worse than that. Right. Of course, learning other subjects are also important, but this is more important than anything else because this is what we gives you the supremacy. Okay. And do you know that in now we are controlled, we are governed by politicians, right? Politicians. Now, out of these politicians all over the world, what is the majority of politicians' job? So, politicians govern us whether we like it or not. So, if you take the majority of the politicians, they are lawyers. And what is the main subject of lawyers? Law, right? Everyone will say the main subject is law, but actually their main subject is logic. So, when they are going for a courts, right? What they do, argue. So, argue. So, arguments are based on logic. So, basically, their bread and butter is logic. And they are really good at logic, and no wonder that they rule us. They rule us. So those who know logic rule us, right? And you know that we were under the colonization of Portuguese, Dutch, English, right? 1500, 600, 700, I think about 500 years. So how they managed to colonize us, not only us, right? Even big countries like India, huge country, colonized by British people. Just set of people come and control us. Not entire London or right thousands, millions of people came here to control us, right? They just controlled us, right? They ruled us. Why? Now, if you look at the base names in logic, Boolean, De Morgan, Venn. Okay? So these are all logicians. These are all British people. And others are also French, German. So this logic subject is mainly built by Western European countries. And no wonder they colonized the entire world. It's they colonized Sri Lanka, not we went there and colonized Britain because they are logical thinkers. So they even went past us and colonized Australia because they had that confidence because they got that logical thinking, whether we like it or not. So therefore, this is your main tool of freedom, power, control. I am not asking you to control others, but at least make sure that you are not being controlled by others too much. Okay. And now remember the lawyers used to be the number one in logical thinking because that was their bread and butter. But now it's no longer the lawyers. Who knows logic most? About 20, 30 years ago, lawyers. But right now, who knows logic most? IT professionals, computer scientists. Because we know, we study about logic 100 times bigger than what lawyers think about it, right? 100 times. Because we now were more into the AI, artificial intelligence. We have built logic processing machine, right? Lawyers don't know how the computer work, how the logic process data in computer, how the artificial intelligence is built. Lawyers have no clue unless they have IT degree or computer science. But we know. So therefore now, whether you like it or not, I hope you like it. IT professionals, computer scientists, computer engineers rule the world. Okay, because we are the guys, we are the ones who knows about logic mostly. We are the ones who make our bread and logic as our bread and butter. And that is why if you take the most of the most wealthiest people in the world, in the top 10 list, at least about 5 to 6 are IT people. Okay, IT people. Mark Zuckerberg, Elon Musk, he started as IT, right? Jeffrey Bezos, Il- the founders of Google, Larry Page is there. So they are all from IT because if you are a logical thinker, you have better chance of success in business, politics, everywhere. But politics is a different story because politics depends on democracy. So democracy means you need to get the consent of the majority. So therefore, it's a different story right now, right? Because it's not your logical thinking, it's the logical thinking of the people that matters, right? For example, if you want to be the leader of a donkeys, so you want to prove that you are the best donkey because donkeys are not going to select, right, the horse as their leader. Donkeys are going to select a donkey. So that is why I'm telling politics, it's a slightly different story. So politics, you will need to be a cunning person. So best fox will become the leader of the donkeys. That is a different story. But in other areas, the logical thinkers always get the best. Okay. So just keep it in mind. Okay. Right. So therefore, whatever the techniques you can use to understand logic, use it. Right. Try to understand it to the maximum. Right? Try to understand it to the maximum. So don't settle for anything less. Right. So therefore, one approach of understanding Boolean logic or to help understanding Boolean logic is try to understand with the help of sets. Of course, it doesn't mean that you must understand set to understand Boolean logic, but it's another access point, right? Sets, Kulaka. Because there's a one-to-one mapping between sets concepts and Boolean logic concepts. One-to-one mapping. Okay. So therefore, we are going to do a bit of, anyway, you have sets and logic is half of your semester 2 math syllabus. But we can't wait until semester 2 maths because math subject is unfortunately in semester 2 and computer system is in semester 1. Okay. We are going to do a bit of a revision on what you have learned in your grade 8, 9, 10 sets. Okay. So we are going to look at very briefly what is a set, what is a universal set, what is an empty set, then what are basic set operations and how these are mapped into the logic operations and how these concepts in sets map into the Boolean logic concepts. Okay. But anyway, we are going to revisit these in semester 2 maths. Okay. Right. What is a set? So remember, you are now supposed to think seriously, right? If you want to be a doctor, engineer, entrepreneur, so you must be a serious person. Otherwise, you can't be a good engineer, good doctor, right? So therefore, always think twice. See whether there's something more you can add. Something more doesn't mean that you make it lengthy, right? So what is a set? So when someone asks what is a set, so you must think about, okay, what are the related concepts? Okay, what is a number? And what is a alphabet, or what is an alphabet, or language, right? So then maybe what is a series, sequence, what is a matrix? So ඒවගේ තියෙනවනේ නේද කතන්දර ටික. Right? So likewise, now you need to give a specific answer. It must not be a common answer, which is applicable to any of these, right? So what is a set? What is a set? So when you learn more and more science and maths, you will learn more concepts like what is a vector, right? So what is a set? And of course, you will, if you go into the more and more maths, you will learn what is a ring, collection. There's something called abstract algebra, right? What is a set? කුලකයක් කියන්නේ මොකක්ද? So set is a collection of elements having following properties, right? Collection of elements having following properties. What are those properties? First of all, it must be well defined. So you can't say something is a set, right? It's not well defined. So it must be well defined. Then it must not have duplicate elements. Same element cannot be there more than once. And the order must not be important. If someone says order is important, that's it. It's not a set. Okay. So if you have well-defined set collection of elements where no duplicates, order is not important, that is a set. Okay. That is a set. And your set can be from any domain. There's no restriction. It can be set of numbers, set of colors, set of letters, set of things, concepts. As long as it is well defined, no duplicates there, and order is not important. Okay, so that is called set. Is it clear? And if you can find a better definition for set than this, I would like to know about this, because I can update this slide. Because I prefer to give you the best, maybe the next set of batches. Okay, so therefore, whenever you are asked a question or something, you also try to give the best. Always try to give the best to others. Right? Give the best to others, not anything lesser than that. Don't settle for anything lesser than that. Try to give the best. Right? Best answers, best solutions, best software. Right? Right. So let's take some examples. Just see whether this satisfies the definition of a set. Well defined, no duplicate elements, order is not important. Integer numbers between 1 and 5. And we know that integer numbers between 1 and 5 are 1, 2, 3, 4, 5. Integers can නිකිල පූර්ණ සංඛ්‍යා, positive or negative, including 0. Yes, right? Of course, when we write, maybe we write it in this order, but it doesn't mean that this order is important, right? If someone says 2, 3, 4, 1, 2, 5, still it's okay. Okay. Students in our class, say we have 5 students, 4 students. So it's a set, because same student is not twice. We don't care about their order. As long as we don't care about their order, yes, it's a set, well defined. Right? Vowels in English language, it's well defined. And these are some examples of not a set. So see whether these violate any of these rules. So you can see duplicates. So duplicates are not allowed in a set. If duplicates are there, it's not a set. So this emphasizes the order. After level 1, go to level 2. After level 2, go to level 3. That is not a set. Order is important. In ascending order. Integers from 1 to 5 in ascending order. Aurora period. So that is not a set. It emphasizes the order. 3 random numbers. That is not specific, right? For one person, it can be 10, 8, and 9. For another person, it can be minus 512. So if it is a set, everyone must be able to agree these are the elements. So something random things are not sets. Sometimes you may have never thought about that, right? Set is this much of serious concept, right? සමහරුන්ට එහෙම හිතෙන්නේ නැහැ නේද? Set එකක් කියන්නේ collection of elements එච්චරයි. That is ordinary level thinking. ඒක තමයි කියන්නේ සාමාන්‍ය පෙළ කියන්නේ. සාමාන්‍ය චින්තනයෙන් බෑ අපිට ලොකු වැඩ කරන්න. So you must be more serious. Okay. Right. So the next concept is related to sets. Universal set. Right. Universal set. සිංහලෙන් අපි කියනවා සාර්වත්‍රතා කුලකය. ආයෙත් නිකන් උත්තරයක් දෙන්න පුළුවන් මේකට. Ordinary level answer. But again think, right? Is it the best in the world? Because you are supposed to give the best to the others, even in an exam answer sheet. Don't settle for anything lesser than the best, the perfect, as much as possible. Okay. So what is mean by universal set? සාර්වත්‍රතා කුලකයක් කියන්නේ. ඔකට දෙන casual answer එක තමයි එච්චර හිතන්නේ නැති කෙනෙක්, සාමාන්‍ය කෙනෙක්. සාමාන්‍ය කෙනෙක් කියන්නේ අර වගේ වෘත්තීන් සුදුසු මදි. තාම. ලොකු responsibility එකක්. එයා කියයි ඔක්කොම තියෙන කුලකය කියලා. ඔක්කොම තියෙන කුලකය කියවම අපේ ගෙදර තියෙන කුල්ලත් අයිතිද? අල්ලපු ගෙදර ඉන්න බලු පැටියෙකුත් අයිතිද? ඇයි ඔක්කොම තියෙන කුලකය? So therefore universal set is not like that. So then there's only one universal set in this world, right? ඔක්කොම තියෙන කුලකය. So universal set is another concept in sets. Okay? Concept in set. And it has a precise definition. So this is the definition of universal set. Universal set of given sets is the set containing all the elements of total interested context. Right? It must contain all the elements, but it doesn't mean all the elements in the world. ඒ ලෝකේ තියෙන ඔක්කොම elements නෙමෙයි. Of our total interested context. ඒ කියන්නේ අපි අපේ අවධානය අපේ interest එක තියෙන context එකේ සන්දර්භයේ ඔක්කොම elements ටික තියෙනවා. It depends on our context. Context කියන්නේ බර වචනෙන් කියනවා නම් සන්දර්භය. Big picture එක. Maybe we are not interested beyond that. So then you don't need to take those as part of your universal set. Okay? And it depends. It's something that you and I need to agree. For each scenarios, each discussions, we can agree this is our universal set. Okay? And in Venn diagrams, we show the universal set like this. That is why we have a limitation. Right? අපි limit කරලා නැති මෙතනින් එහා යව නැහැ. ලෝකේ තියෙන ඔක්කොම නම් මෙතනින් එහා කොටුවක් ගහන්න නැහැ. Simply we are not interested in these things. This is our interested context. And that is our universal set. But it must include all our sets and any other elements that we are interested, though they are not part of these tests. But maybe still we are interested about this. Maybe this one we are not interested. That is why it's outside the universal set. Okay, so therefore this is it depends on our context. Remember, we need to be very serious, right? So those who are the highest level of seriousness, so they are the most logical thinkers, right? So they can think about concepts beyond what the ordinary people can think. For example, we all know that Einstein is a very serious person. And still, I don't know, I can't understand what Einstein has told, right? Because I am not as good as Einstein. Right? But there are some people, right? Some professors, so they have a better sense about what the Einstein has told, its theories. Right? So there are people who has better sense about how the computer works. For example, if I'm offered a job to come and work in Intel as a processor architect, processor designer, or even as an engineer, I will not take that job. One thing is, electronic is not my subject. Other thing is, I think that level of capacity I don't have designing a microprocessor. But yes, I can involve in designing a software, right? That capacity I have. So that is why I selected those challenges. So it depends on my personality, my likings, my skills. Okay. Right. So therefore, whatever the area, first try to be very serious if you are really interested about that area. Or else forget about that area. Okay.
රයිට් එක නම් ඕගොල්ලන්ට බලා ගන්න පුළුවන් කැප්ටේ ඉස්සරහම තියෙනවා ඕගොල්ලන්ට group top එකට ගහන ස්පෙෂල්ම මැටීරියල් එක මේක තමයි අප්ඩේට් එකක්.
I think someone has
voting එක
I think someone has unmute your microphone. No, we can hear some audio. Okay. So just make sure that you mute your microphones or audio. Okay. Right. So therefore, be very serious when you answer or when you think about these concepts. So what is universal set? All the elements that we are interested in the given context. We are not interested anything outside that. So then that is universal set. So then you must be able to give examples. Right? So you must be able to give examples. That is how you double check whether you have understood. Can I define it precisely? Can I give some practical examples? Can I use those concepts in real world? So then yes, you know it. Okay, you know it. Right. So these are some examples. Say we have set of sets. Set A. Students following an IT degree at Aurora or Somerset or whatever. Set B. Students following a business degree at Aurora or Somerset. So then someone will ask, what is the universal set? Again, I can't say this is the universal set. Maybe you and I can agree. Okay. For example, if we are interested in our institute, if we are talking about our institute as a bigger context, a possible universal set is student at Aurora, or student at Somerset. Right? But if our discussion is much broader, maybe students in Sri Lanka. Even bigger context, it can be students in the world. Or maybe student following a degree in Sri Lanka. It all depends on your context, which one you are interested, which one you are not interested. Okay. But once you agree, yes, you can say this is your universal set. So then make sure you don't go beyond that. Because then your universal set is, if you go beyond that and think about it, discuss it, then your universal set is no longer valid. You need to update it. You need to agree on a different universal set. Is it clear? universal set, right? There's nothing, right? No one can say this is the universal set, right? But we can agree in democratic manner, yes, let's consider this as universal set. For example, if vowels in English is our set, a possible universal set is alphabet in English, most probably, because we are interested in vowels in English. Okay. So these are all possible universal sets. So the next concept is null set or empty set, abhishunya kulakaya. So that is somewhat easier to understand. So this is just like understanding zero as a number. We all know that zero is a number. So what about empty set? Empty set is a set having no elements. So set is a concept, right? You must be able to define it. But if when you define it, if there are no elements, then it's an empty set. Then it's an empty set. Of course, you can think of concepts like that in any context. Okay. For example, right now, students in this online session, it's not an empty set because there are about 8, 9, no, whatever students in this session. Maybe after 6 p.m., maybe everyone has disconnected. So then students in this session is an empty set. Still, I can say student in this session, but maybe no students are there on online. So then it's an empty set. And logically, we can build also, right? For example, numbers between 1 to 5 or integers between 1 to 5, it's not empty set. But if I say negative numbers between 1 to 5, yes, it's an empty set because the concept is there, but no elements. Okay. And you can represent using 5 just starting and in curly braces. So you can just explain a story where no elements are there. Right? Empty set or null set. Okay. So then we have the set operations. You know the set operations, right? Intersection operator, chedana, union, mele, complement. So, so you must have idea about those and be very serious. Be very serious. For example, if I ask, can you use in simple English, explain what is mean by if you have two sets A and B, what is mean by A union B? I'm pretty sure more than 50% of the student give me a wrong or non-serious answer. Can anyone give me answer? Don't worry, right? Maybe you are in that non-serious 50% or serious 50%, right? Don't worry, right? I'm not going to judge you. But you must have the guts at least to give an answer for that kind of question. At least some of you. Can you explain what is mean by A union B in a simple statement, full sentence? This is what A union B is. All elements of set A and B. Right? That is the exact answer I expected. Right? So I will rewrite it. All the elements of set A and B. Now can someone explain me how do you define A intersection B? For the same student or anyone else? I prefer to get the answer from the same student. How do you define intersection? ඡේදනය කියන්නේ මොකද? I prefer to get that answer. දැන් ඉතින් ඔයා එක්කෙනෙක් අහු වෙලානේ තියෙන්නේ දැන් ගිරේට. එයාලා දැන් දිගටම බෙල්ල දෙන්න වෙනවා. But at least you have that guts, okay? What is mean by A intersection? Can you give me a similar definition? Because you can't give me the same definition, right? For two concepts. Now that is why when there's a serious problems, legal issues, you send your lawyers to talk on behalf of you rather than you go and talk. Because sometimes what you mean is not what you say. Right? ඔයා හිතන දේ නෙමෙයි ඔයා එකක් කටින් කියවෙන සමාන. But remember the main subject of lawyers logic. මං කෝ ඒගොල්ලෝ අපි තරම් logic දන්නේ නැහැ but ඒගොල්ලෝ සෑහෙන logic දන්නවා. හැබැයි ඒ වගේ සියුණක් අපි දන්නවා. හැබැයි සාමාන්‍ය ලෝකෙ ඉන්නවා lawyers. එතකොට අපි lawyer යවන්න ඕනද? So they are very serious about these words. Right? ඒකෙන් lawyers කතා කරද්දී පොඩ්ඩක් හිමින් කතා කරන්නේ නේද? එක දිගට කතා කරා යන්නේ නැතු. Okay. So basically in logic, intersection is related to and. And that is why in logic we have this symbol in maths for and, which very close to this. But in logic, union is related to O operator. So therefore, when you explain union, you need to use O. Elements that belong to A or B. A or B. That is what A union B. Intersection is belong to A and B. A and B means both. Now you can see. Okay. So that is now you can see why we send one thing is lawyers know the law. ඒගොල්ලෝ දන්නවා මේ වගන්ති තමයි law එකේ කියලා. අනිත් එක second reason. So they are more serious about logic. And of course, we are 100% more serious about logic than lawyers. Okay. As IT professionals, because we design these things, logic circuits. They don't design logic circuits. They don't design AI. They don't build AI. Okay. Right. So therefore, there's a big connection between logic sets, logic operations, set operations. And complement is not belong to A. Okay. Right. So these are the logic operators. The not operator. So not operator means negation. True become false. Not true is false. Not false is true. This is the mathematical symbol we use. Right. And in sets, it is complement. Belong to A, not belong to A. So there's one-to-one mapping between logic operations, Boolean logic operators, and set operators. So not operator, not Boolean logic operator. So the next one is AND operator. And so there's a one-to-one mapping between AND operator and intersection. Right. So this is the truth table for AND operator. When both are true, only true. If at least false, the result is false. Okay. For example, you must have credit for both maths and English in O level and A level, minimum 3 passes. So if you don't have credit for O level maths, so you are not qualified for BIT because there's an and. Okay. So then there you have either A level or FIT. Now, if you haven't got the 3 S passes for A level, but you have passed FIT, yes, because it says O and O. So you must pay attention to those things, right? සමහරට කැපිටල් වලින්ම ලියනවා විශේෂයෙන්ම BIT වෙබ්සයිට් එකේ මොකද අපි IT කරන අය හොඳට ලොජික් ගැන කෙයා කරනවානේ. Admission requirements. And O මේ තියෙන O කැපිටල් වලින්ම ලියලා තියෙන්නේ. මේවා O මේ එකක් හරි සැටිස්ෆුනා මැති. Okay. But here we have an. කියන්නේ මේක වෙනම සැටිස්ෆයි වෙන්න ඕනේ. මේක එකක් වෙනම සැටිස්ෆයි වෙන්න ඕනේ. Right? That is how the AND logic work. At least one of these and at least one of these. Right? ඒක කියන්නේ මේකෙන් දෙකක් සැටිස්ෆුනා මැති කියලා. No. You must have satisfied at least one from this side and one from this side. Okay. So that is how AND logic work. When both are true, only true. Otherwise false. In sets, it is intersection. It must belong to both A and B. A and B. So that is why we use very close symbol also. This is intersection, this is an in maths. Okay. So then the O is pretty much in sets union. Right? Either belong to A or B in sets. Or both. So therefore you can see either A is true or B is true or both. Both is also union. But if not belong to A or B, none, that is not shaded, right? This is not part of the union. That is false. So likewise, you need to think about these things. Seriously. Seriously think about AND. Seriously think about O. Seriously think about NOT. And seriously think about XOR. Okay. So in O, when at least one value is true is enough. If both are true, still okay. For example, you need to have the ID card or passport. So if you have only the passport, yes, fine. If you have only the ID card, fine. If you have both, still fine. But when they say you need to have admission and ID card, if you don't have the admission, you are in trouble now because it says and. Maybe they will say admission and ID card or passport. So then either admission and ID card or admission and passport. So when you go abroad, you need to have both passport and visa. So if you have only one of those, no, you can't. Unless they have the on arrival visa. Okay. Right, so the next one is XOR. So XOR is an interesting guy. I told you XOR is not a basic operator. But because XOR is heavily used in logic, digital electronics, we give it a separate symbol. We give it a separate symbol. Okay. So not means basically negate. If the original is true, not is false. If original is false, the not is true. Right? So that is the easiest to understand. Negate. Right? Pass in the exams, not pass in the exams. Okay. Say to pass, you need to get more than 50. So then if you have not more than 50, you have failed. So that is negation. Not make it negate. If original is pass, now fail. More than 50 pass, then not more than 50 fail. Right, XOR operator is the interesting guy. So why do I say it's an interesting guy? Because remember, we as humans we were not very serious about logic early days. Early days means even remember Pythagoras theorem was found or discovered Pythagoras theorem. Right? So that is this say a squared plus b squared is x squared or c squared. So when did this theorem was discovered by Pythagoras? Roughly මොන කාලේ කියලාද ඔයගොල්ලෝ හිතන්නේ? අවුරුදු කීයකට විතර කාලෙද? So then what about Boolean algebra? Boolean algebra මේ Venn diagrams Boolean ඉපදුනේ 1800 ගණන්. So 1800 means now 2020. 1800, 1900, right? About 250 years. ඔන්න ඔය වගේ කාලයක තමයි බූලියන් ලොජික් කියනවා seriously මිනිස්සු කල්පනා කරේ concept build කරේ 250 years ago, right? 1800s. Boolean, Venn, De Morgan, right? About 250 years ago. This is Boolean logic. But what about Pythagoras theorem? So this Pythagoras was there even before Jesus. So before Jesus, Pythagoras was there and developed these theories. So that is more than 2000 years. Okay. I think even somewhere the close time frame as Buddha, right? Maybe 2200 years ago. So about 2200 years ago, they came up with Pythagoras theorem, but only about 250 years ago, they were very serious about logic. And the funny thing is, even in almost all the languages, we don't have a word for exo. So in English, we have a word and, we have o, we have not. These are English terms. In Sinhala also we have saha, ho, naha. But in English, there's no word exo. This is only for the engineering. In Sinhala, there's no word because we were not very serious about exo until these guys analyze these things. Right? But when we build computers, electronic devices, no, definitely EXO is different from Mo. So therefore, we had no other option, come up with a new term, EXO, new symbol, but no English term. Because we were not serious about differentiating between O and EXO at that time. Only about 200, 500, 250 years ago, we thought, okay, this is two different things. We need new word, new symbols. So therefore, what is EXO? It's a simple concept. So EXO means something like O, but both can't be true. Both can't be true. If when both are true, again we take it as false. So exclusively one value must be true. So again you can visualize it using sets. Right? So this is EXO. If it is O, this part is also there. So the funny thing is, even today, when we say O, most of the time we mean O, but sometimes we mean EXO. So that is funny thing, right? For example, when your mother, so you are going to the supermarket, your mother will say, bring Astra or anchor butter. Astra margarine or anchor butter. Or anchor or ratti. So when she says anchor or ratti or highland or anchor, actually what she means is EXO. But she doesn't say like that because we are very casual. But actually the expectation is that, for example, if you bring ratti, not anchor, she's fine, or not highland, she's okay. You bring highland, not ratti or anchor, she's okay. You don't bring anything, she's not happy, right? You bring both, she's not happy. Why? When she say oh, actually what she means is EXO. Because we use O for both the O and EXO. So then, as humans, we need to understand what does this man or this person really mean. Is it really mean O or EXO? That is the fuzziness. But good thing about computer is, in computer, we have two different logic gates, XO, O. In programming languages also we have the O operator, XO operator. That is why computers are one of the reason why computers are more reliable. We explicitly say O, XO. We don't say O and say ask other guys, you decide using your common sense. Right? So XO. Okay. So exclusive one value must be true. Okay. And why XO is not considered as basic operation, because you can write it using others. That is belong to A and not belong to B, or belong to B and not belong to A. So therefore XO you can write like this. So that means you can write it using and, O and not. Right? So that is why it's not considered as a basic operator, but it's a very important operator. And most of the time we really miss it in common world. Okay. Right. So we'll stop at this point. Now we are in the halfway of the theory part of the logic. So we want to finish the theory part and then move on to the how to use logic in computer or digital circuit designing. Okay. Right. So we stop at this point, right? Thank you.